In this problem, we're given information about a data set of brain volumes and IQ scores of 7 males. And we're told that the linear correlation coefficient is R equals 0.905. So we're going to use the table to find the critical value of R, and then we're going to determine if there appears to be a linear correlation. So what I do to start this kind of problem is I draw a number line, and I'm going to mark the ends and the center, roughly. And this is -1, 0, and 1, because the values of R can only range from -1 to 1. Now we know that in our particular case, the linear correlation coefficient is right about here at 0.905. Now, that would seem to indicate a positive linear correlation because it seems very close to the number 1. But what I have to do is I have to look at what the critical value of R is in this particular case. Since there are 7 males, that means that there are 7 pairs of values, and that means that our critical value is 0.754. So I'm going to mark that here. And if we were interested in the negative side, we would mark a negative 0.754. And what this tells me is that because we're falling into this upper region, our correlation coefficient is falling into that upper region, there is a positive linear relationship between the brain volume and the IQ. If our correlation coefficient had fallen into this center section, then we would have said little or no correlation. And if our value had fallen down here, then we would have said there was a negative linear relationship. But in this particular case, we do have a positive linear relationship, and so that's our final answer. So our critical values were plus and minus 0.754, and then we would say that there was a positive linear relationship. So that's how you do that problem.